All right, let's get straight to the facts. Is a heat pump actually worth it right now? Well, the truth is, the fundamental numbers dictating home heating economics have completely transformed in 2026. Seriously, those return on investment calculators you find online from 2023 or 2024, they are entirely obsolete. Today, we're not just looking at generic manufacturer brochures. We are looking at the hard data to uncover exactly when a heat pump is an engineering marvel that saves you thousands and when it is, honestly, a massive financial trap. We really need to look past the marketing hype here and focus strictly on the underlying math that dictates whether this technology actually belongs in your specific home. I mean, just look at the sheer scale of what is happening right now. In just the first 3 months of 2026, 575,000 heat pumps were sold across 11 European countries. Take a second to process that number. That's a massive 17% year-on-year increase. In places like France, Germany, and Poland, sales surged by around 25% on average in just one single quarter. It feels like everyone is switching. The momentum across the continent is absolutely undeniable right now. It literally represents one of the fastest infrastructure shifts we've ever seen in residential properties. Okay, let's dive into this, because here is the uncomfortable question that nobody is really asking out loud. Are all of these 575,000 homeowners actually saving money? The reality is, some buyers might be in for a very unpleasant bill. You see, a heat pump isn't some kind of magic box that just infinitely prints free heat, despite what a slick installer might promise you. It's a highly sensitive engineered system, and if you don't fully understand the environment it operates in, you could lose a serious amount of money. To avoid that trap, we've got to completely rethink how we measure heating costs. Because whether a heat pump will save you money depends entirely on one specific variable. It's a number your installer will probably never show you, and it varies wildly depending on exactly where in Europe you live. So, let's look at Section 1, the number deciding absolutely everything. We really have to look at why the old calculations are dead. Basically, it's a structural crisis in gas economics. After the Strait of Hormuz closed in March 2026, we saw gas prices spike violently. But the bigger, much more permanent shift is carbon pricing. Right now, CO2 pricing under the European ETS2 scheme sits around €55 per ton, which directly impacts the cost of your heating fuels. But by 2030, several major analyses project this is going to approach or even exceed €100 per ton. Think about what that actually means for a typical gas boiler over a 20-year lifespan. You're looking at €9,500 in cumulative carbon costs alone. That is just a penalty for running your existing system. The ground hasn't just shifted beneath our feet, it's fundamentally changed. Relying on fossil gas is structurally becoming a really expensive habit. Notice the pure thermodynamics at play here. A modern condensing gas boiler basically burns fuel to create heat, right? It's a mature technology and it's efficient at what it does, sure, but it is thermodynamically limited by the absolute laws of physics. For every 1 unit of energy you put in, you get about 0.9 units of heat out. You inevitably lose some of that energy out the exhaust. Now, a heat pump, however, doesn't actually generate heat in the traditional sense. It moves heat from the outside air, ground, or water directly into your home. It acts as a massive energy multiplier. You put 1 unit of electrical energy in to run the compressor, and you pulse 3 units of heat energy out. It literally leverages the ambient environment to multiply your input. And that incredible multiplier effect brings us to the most vital metric of this entire explainer, the COP, or coefficient of performance. This is the exact measurement of how many units of heat your system delivers for every single unit of electricity it consumes. Field measurements from all across Europe show that a well-optimized system, one paired with good insulation and running at low flow temperatures, will easily hit a COP of 3.5 to 4. But a poorly set up system slapped onto a drafty house with outdated radiators, that efficiency drops to a disastrous 2 or 2.5. It means you are paying significantly more for the electricity to run the system without getting the promised heat in return. And this brilliantly illustrates the golden rule of thumb for this entire technology. Because your heat pump delivers about 3 units of heat for every 1 unit of electricity, it only makes financial sense if your electricity costs less than 3 times the price of gas. Let me just say that again so we're absolutely clear. If electricity is exactly 3 times more expensive than gas, and your COP is exactly 3, you just break even. Zero savings. You're simply trading one fuel bill for an identical electric bill. The relationship between your local utility rates and your system's coefficient of performance is the single heartbeat of your return on investment. If you don't grasp this ratio, you're flying completely blind. Moving right along to Section 2, the country-by-country breakdown. So, how does this actually play out in the real world for you? Well, we need an X-ray perspective of the European landscape.
Looking at the overarching physics applied to different local economies, you can see immediately that the baseline reality in France is completely different from the reality in the UK or Germany. Let's break these down one by one so you can see exactly where you stand, because I promise you the economics shift dramatically the second you cross a border.
Let's start with France and Italy. France is an absolute powerhouse here. It's genuinely impressive. Driven by an abundance of cheap nuclear power, their electricity to gas price ratio is roughly 2 to 1. That is comfortably below our critical 3 to 1 threshold. And when you add in massive government subsidies that cover up to 15,000 euros, it becomes an undeniable win, which is exactly why they already have 5 to 6 million heat pumps installed. Italy sits in a very similar operational sweet spot with a ratio between 2 and 2.5 to 1, with aggressive government subsidies covering up to 70% of installation costs and a carbon emission reduction of 73% compared to fossil gas. The financials for homeowners in both of these countries are just incredibly strong right now. Now, Germany, on the other hand, requires a much deeper look at the engineering and economic trade-offs. The electricity to gas ratio here actually exceeds 3 to 1. Gas is relatively cheap and electricity is expensive. And to make matters tougher, installation costs in Germany are incredibly high, often running between 18,000 and 30,000 euros. From a pure unsubsidized mathematical standpoint, the payback period is painfully long. But the calculation changes when you factor in government support covering up to 70% of upfront costs, combined with those looming 9,500 euros in gas carbon taxes we talked about. Plus, you've got to factor in rapidly rising gas network fees. Why? Well, as more of your neighbors switch to heat pumps and leave the gas grid, the cost of maintaining that vast gas pipe infrastructure gets divided among fewer and fewer people. So when you look at the total picture, a heat pump transforms from a really tough sell into a viable, protective necessity against future energy shocks. The UK presents a truly fascinating tariff trade-off. Their ratio is one of the toughest in Europe, at roughly 3.8 to 1. If you run a heat pump on a standard UK electricity tariff, it actually costs about £30 to £40 more annually than running a standard gas boiler. You're at parity, but technically, you're slightly losing money. However, if you utilize the £7,500 boiler upgrade scheme grant and, crucially, switch to a dedicated time-of-use heat pump tariff, the entire equation flips. A time-of-use tariff just means your electricity is priced dynamically, allowing your system to do the heavy lifting of heating your home or hot water overnight when grid electricity is significantly cheaper. Doing this cuts your running costs by 30 to 40%. Suddenly, that slight loss flips into a massive £3,900 saving over a 20-year period. And then there's Poland, which is an entirely different story. Their massive 25% sales growth isn't really about moving away from gas. It's almost entirely about ditching coal. This makes for a phenomenally strong financial and environmental case, because homeowners are competing against the high running costs and, let's face it, dirty reality of coal-fired central heating, and because their local installation costs are roughly 1/3 of what you see in Germany, the barriers to entry are significantly lower. Upgrading to a heat pump in Poland isn't just some marginal efficiency gain. It's a massive transformational upgrade for both personal household finances and broader urban air quality. Which brings us to Section 3, your 3 rules for success. So the absolutely crucial point we need to establish here is that a heat pump is not a plug-and-play appliance. It's not a toaster. You can't just drop it into any house and expect miracles. Whether you actually see these projected savings in your bank account comes down to 3 mandatory variables. First, you must know your local electricity to gas price ratio. Second, you must maximize your system's real-world COP through smart engineering. And third, you must secure a dedicated time-of-use tariff to drastically lower your electricity input costs. Get all 3 right, and you are confidently saving 400 to 1,000 euros a year while cutting your personal emissions by up to 70%. Fail on these, and you're losing money. It really is that simple. Let's zoom in on that second pillar for a second, your real-world COP. Think of your home's insulation as your thermal shield. If your shield is weak, leaky, and drafty, your heat pump has to work twice as hard, running at extremely high flow temperatures just to keep up with the heat escaping through your walls and roof. That completely destroys your coefficient of performance, dropping it well below 2.5. Skipping the insulation step turns an otherwise viable engineering investment into a catastrophic financial money pit. Insulation is not just a comfort preference, folks. It is the mathematical foundation of your return on investment. You absolutely must seal the envelope before you install the tech. Wrapping things up with Section 4, your 2 possible futures. As we look at the structural data dictating European homeownership over the next 5 years, it becomes abundantly clear that every single homeowner is currently standing at a crossroads. There are exactly 2 possible futures ahead of you. In future 1, you wait. You stick with the status quo because, well, it feels safer. But the status quo is fundamentally changing beneath you. You will inevitably face rising gas network fees as your neighbors disconnect, and those punishing CO2 carbon taxes we talked about. Every single year of delay costs between 3,000 and 7,500 euros in cumulative lost savings. In future too, you take control of the situation. You insulate your home, you optimize your system's COP, you secure the right time of use tariff, and you watch your electricity bills fall as the national grid gets greener. Meanwhile, the gap between your steadily low bill and your neighbor's continuously rising gas bill widens every single year. The technology works, and the math absolutely works across most of Europe if you strictly follow the rules of the system. So I have a final question for you to consider. Which country are you in, and are you currently heating your home with gas, oil, or coal? Take a hard, honest look at your own setup right now. And you really need to figure this out quickly, because in our next explainer, we're breaking down the upcoming EPBD deadline. It's a looming regulation that most European homeowners don't even know about, which will directly and severely impact your property value and your future mortgage rates. You definitely won't want to miss it.